Okay, this is from our trimester one review packet. This is question 12 from the more difficult questions or more challenging questions for paper one. This is about counting theory combinatorics. So let's just look at it. A team of four is to be chosen from a group of four boys and four girls. Find the number of different possible teams that could be chosen. Okay, so what this comes down to is this is realistically just n choose r. This is directly from binomial theorem. So we are looking for a situation where we have 8 choose 4. And that'll just be the total number of different teams that are chosen. We don't have any limitations on it. So to do that, I am going to go ahead and use my calculator. Well, actually, this is paper one, so we can't use our calculator. So n choose r. The n choose r formula is NCR is n factorial divided by r factorial times n minus r factorial. So this would turn into 8 times 7 times 6 times 5 times 4 factorial. I'm leaving that as 4 factorial just because under here I'm going to end up with 4 factorial. So it just makes sense to leave it as that. Actually, I'm going to get 4 factorial there. So I'm going to rewrite this as 4 times 3 times 2 times 1 times 4 factorial. Again, I'm doing that just because I know that these will cancel. And then it's just a matter of seeing what else I can cancel. I can get rid of that 6. If I divide 8 by 4, I'm left with 2. So overall, this would give me my denominator is going to go away. So this is 2 times 7 times 5. 7 and 5 is 35 times 2 is 70. So there's 70 possible different combinations of these 4 boys, 4 girls that we are choosing to make a team. So 70 would be our answer. That's part one. I think that's manageable. It's just a matter of recognizing that when we have a group that we are choosing from, that becomes our n, and the number of people that we are choosing from that group becomes our r. So recognizing that. Then find the number of different possible teams that could be chosen, given that the teams must include at least one girl and at least one boy. Oh boy, this is how they love to ask questions. But what we have to recognize, we are looking for all of the possible teams that have at least one male and one female. So, wow, I can spell words. Yikes. So what we could do with this is a lot of times it's easier to think of this the opposite way. At least one girl and one boy. Well, how many different scenarios, different ways can we have all boys or all girls? Well, if there's 4 boys and 4 girls, and we're looking for a team of 4, there's only one situation that gives us that, and only one other situation that gives us all girls. So overall, the only way, because again, if there are 4 boys, there's only one combination that gives me all 4 boys on a team of 4. We don't care about the order. It doesn't matter if it's boy A, B, C, and D are chosen, or if it's D, B, C, and A. We don't care which way they're chosen. Just the team is made up of all 4 boys. There's only one way of doing that. Similarly, there's only one way of doing that with girls. Now, if there was more girls, there was 5 girls, then that would change the ways that we could organize that. But right now, there's only one way of doing that with girls and one way with boys. So what this would be is, out of from our previous answer, 70 possible teams. Wow, life is not working out in my writing today. Out of 70 possible teams, well, if we just take the two possibilities away, then we would be left with there are 68 possible teams with at least one boy and one girl. And I think that's what the question asks. Find the number of different possible teams we could be chosen given that the team was at least one girl and one boy. That's where we're at. That's going to be 68. I hope that makes sense. A lot of this just comes down to a little bit of logic and then applying the math that we know. I hope that's